Waves are not just on the beach, waves are all around us. Some waves are obvious, but most are invisible. These waves are utilized in modern technology. Some waves allow us to communicate around the world. Some waves let us see far in the distance. In this documentary, we will explore 3 modern technologies and the waves they rely on. So in this experiment, we'll be finding out the relationship between frequency, velocity, and wavelength. But firstly, how does a radio work? Waves are all around us in different frequencies and wavelengths. Some can be seen by the naked eye. This is the visible spectrum, which is the band between 430 and 770 terahertz. Radio waves, microwaves, infrared waves, and many other waves are either too high or too low to hear or see, but that does not mean they don't exist. Generally, radio waves fall into 2 distinct types of waves, AM waves and FM waves. Radios work by having a transmitter translating a normal voice wavelength, such as someone talking or music, to waves of a higher frequency, thus making it easier, stronger, and faster to send messages over far distances. The initial transmitter changes the original wave to this form. From the transmitter, the wave is sent via cable through the antenna, which is tuned to a set frequency and direction. From there, the wave is sent up in the air to reach its destination. AM broadcasting is a high frequency which has a low sound quality but can easily be transmitted over long distances, reaching more stations, whilst PM is less prone to interference and has a better quality but is, however, combated by physical barriers. From this, they bounce up through the upper atmosphere until they reach their destination, where the radio receiver receives the broadcast and then converts its data, removing the carrier wave from the broadcast in a process called modulation. In this experiment, we're going to create a radio transmitter and view the effects of radio waves firsthand. So, throughout the scene, I'm quickly building a radio transmitter. If I was to show this whole video, it would have been over 8 hours long. Soldering is an art form and requires skill and due diligence before soldering. Remember to ask your parents' permission before soldering at home. Now, since it's done, let's plug it in and see how it works. As we can see, when we go to an empty frequency and tune our radio transmitter to it, we can hear music playing on the radio. The change of frequency also changes the velocity of the wave. In this experiment, it doesn't matter. However, if we were broadcasting citywide or globally, this would be different, as the quality of the wave would decrease further and further it went due to interference. We can see this effect in action here. As we move further and further away from the transmitter, the signal quality decreases and it becomes harder and harder to hear. This is the same wave on an oscilloscope, and this is what happens when the frequency changes. When the frequency is increased, the wave gets steeper and shorter. When the frequency is decreased, however, the wave becomes longer and slower.
Sonar is used by numerous animals in order to hunt or survive. Submarines are basically big metal dolphins and utilize the same technology in order to hunt their prey. Sonar is an echo. This means that it utilizes sound waves. Boats and submarines send out sound waves that travel at approximately 1,500 meters per second through the ocean. Once these waves hit something, they are reflected back towards the sender. Sonar technology times how long these waves take to return, and uses this information to map the environment around it. In this experiment, the ball represents the wave, and the height at which it drops is the height of the marine vessel. Simply having the times recorded means we can calculate how far an object is in the sea. We can map the sea floor then to avoid any obstacles, preventing a cold death in the dark depths. In this experiment, the ball is dropped from 3 different locations. Location 1 is standing up, location 2 is sitting on a chair, and location 3 is standing on the chair. Each of these locations is at a different height from the ground, therefore the ball will take a different amount of time to reach the ground.
Radar. Radar is all about radio waves. Radar sends out radio waves, and if they are in the path of a plane, they'll bounce off that plane, and they will then be received by an antenna, giving you a clear radar blip. Similar to sonar, except that radar can detect very small planes and get a very accurate range of bearing, distance and direction in relation to the antenna. So let's start with the transmitter. This sends out the radio waves. The signal is sent out of the antenna and then travels through the sky If these waves hit a plane or a flying object, the radio waves then bounce back and are received by the antenna. Then the signal travels through a splitter, which splits the received signal and the transmitted signal. The receiver signal is then turned into a display. The display calculates the range and bearing based on various factors, including the time taken for the signal to return and the angle of the incoming receiver signal. Now, radar uses PM waves. This allows them to have greater quality, and the waves can be deflected more easily. This means that storms cause severe issues with radar. If the clouds are thick enough, the storm can block radar altogether.
Radar is essential for air traffic control, defense and forecasting, and must be kept in best possible condition to keep our skies safe. Without radar and other related technologies, there'd be utter chaos in the airways, and planes would not have crucial advanced warning when approaching an obstacle. Waves, whether or not we see them, are an important part of our day-to-day lives. The benefits of using waves in technology has been immense. From something as simple as checking the weather forecast or listening to a song, our world is built around waves.